This morning I'm off to see Raoul from Lucia Technic. You may know Raoul from other videos. He is Mr. Carbon. Anything you need to know about carbon, carbon fibre, carbon manufacturing, carbon composites, he is the man. He lives around the corner. Known Raoul for a few years now, and any questions I have or any concerns I have about carbon, he is our go-to man. So with the TCR I've got it in the back here. The seat post has got a bit of creaking to it as I'm riding along, sort of a bit of a creak. I think it's because there is so much seat post there. There's a ton of excess seat post. So I thought I'd go in, have a chat to Raoul about it, see if we can cut it off, show the process of cutting some carbon up. And while we're there, we'll have a chat to Raoul about his latest Instagram posts that he's been putting up. He's been cutting up a lot of expensive carbon fibre bikes. So hopefully I can have a chat to him about that. All right, we're here. Let's go see the man who knows absolutely everything about carbon fibre. When I get a park. Not sure that's even a park, but that's what the Subi's for. All right, let's go. Okay, we're in to see Raoul today from some work on the TCR bike of mine. But while we're here, Raoul, you've been doing a lot of work on Instagram. Well, a lot of posting up of bikes cut in half on Instagram. What's going on?
Yeah, it's just something, like, I've been cutting up bikes for years because it's a really good way to understand how the bikes are put together and how the technology changes over time. So the technology is constantly evolving. The brands are constantly, in manufacturing houses and factories, constantly trying to find better ways to build their bikes, and so it's a really good way to see where they're at with the technology. So so this one here, we've got a specialised venge, and you can see it's all pretty clean inside. They've got some internal ribs around the bottom bracket to increase the stiffness through there. Pretty clean, it's fiberglass layer there where the water bottle bidden is to prevent the galvanic corrosion or reduce the galvanic corrosion through that area, stop it delaminating when they drill it, little things like that. So it's an interesting way. So in conjunction with the ultrasound scans that I do, with anything with non-destructive inspection, it's all about getting as much information as you can. So you use the scan, you use the visual, you can use a tap test, you can use a fibre scope where you can look inside, getting as much information as you can, and just to understand what's going on with the product. So
excellent. Okay, so this is an X-Works Venge. I've been unlucky enough to see inside a bike myself, but only when it's in pieces. But this is not bad. So that's how they lock those in.
Yeah, that's just compression sort of fittings.
Excellent. Okay, so that's an S-Works. What else have we got? Have you got I think I've seen a couple more expensive frames as well.
Yeah, we got lots of stuff here.
What do we ever got? Well, we'll go through just a quick overview of the other ones.
Okay, so this is a Trek E-Monda SL.
Right.
Fairly new one. It's probably last year. So.
Okay.
So, yeah, like again, you can see the moulding is really clean. Like when you see some of the older frames, like it's night and day to what this is. So, all through here, hardly any wrinkling. It's all clean lines. There is a little bit of funky stuff going on here, a bit of dry fibre. So where the fibre doesn't have enough resin and it's actually come loose, but there's only a few fibres there on the surface. So they've used a plug here to assist with the moulding. We've got a bond interface here, and again with the dropout. So again, well made, pretty clean frame.
I thought I saw a Pinarello as well. Now they've got some wavy.
Yeah, there's
seat stays or.
Here we go. It's this is a Dogma 60.1.
Oh.
So a few years old. But yeah, so this is a few years old and it's just not quite as clean. So more resin sort of wrinkling and little bits going on.
So all the parts we don't usually see, we can see.
Yeah. So you know, little things like, you know, through here you got some wrinkles. I mean, it's not major, and it's primarily resin, but it shows a sort of a little bit less compaction. Right through here, I don't know if you can see those, but there's just a couple of little voids. It's a little basically trapped air between the layers of carbon. Yeah, sort of wrinkles in the bag.
Oh, I can see the wrinkles really clearly through there.
Yeah. Adhesive joint here, you know, good amount of adhesive. You know, sometimes we see bikes which they've got adhesive joints, but they don't have that much adhesive in them.
Right.
So I think I've posted one up on Instagram this morning with an older Trek.
Yeah, right. We'll link everyone to your Instagram account as well so they can follow along, because I think every morning I wake up to something else that's been cut in half that I'm really interested in seeing what's going on. What have we got here? This is more of a time trial.
No, this is a Wilier.
Okay.
Was it the Cento?
There's not much left of it.
No, so yeah, you know, really sort of got stuck into this one.
Right. I can really see the wrinkles through here. But
so yeah, so this is a few years older technology, and you know, like I mean, up through here, like you know, you got a lot of wrinkling and that sort of stuff. So so if the fiber's not being compacted and it's not aligned, then that's a structural deficiency in the frame.
Okay.
So having, like, if it's just resin, then yeah, I mean, it shows that there's not as uniform compaction through there.
Yep.
But if the fibre, and when I say wrinkling, it's fibre wrinkling. It's, you know, so stuff like that. And I can show you on a fork. I've got some cut up forks which really show the wrinkling well, and you can then, you know, it's like a knot in a piece of wood.
Okay.
Timber is the same as composites, basically. It's the same. You've got fibres, and the direction of the fibres is what gives it a strength. So if you have a knot in a piece of wood, the piece of wood isn't very strong. So yeah, so you know, that's sort of an example of probably lesser technology.
So I guess the question I have: would you be worried riding that frame, given the wrinkling inside?
No, it's not a matter of being worried. It's more a matter of what we see is like the older frames. Over time they tend to have they start cracking, and cracks come through as the wrinkles, because they're not carrying the load in the way it's designed to. The fatigue starts coming into play, and so, you know, if you look at a carbon bike from, you know, say 10 years ago, they all had cracks around the bottom bracket because they're all full of wrinkles in that area.
Right. Okay.
So
interesting.
And that's why, like the new ones, the newer technology is just so much nicer. Here's a focus, and this has got the internal cable routing.
Oh, okay.
So it's moulded in. On the down tube, it's reasonably clean. There's a bit of wrinkling going on here, but on the top tube, you can see there's a line of voids along that radius, basically, just because it's the corner's a little bit tight because the fiber's got to fold around that sort of tight corner, but then also over the internal cable routing piece. So, and here's a bit of the bag. So that's the compression bladder. So
that's still in there?
That's still left in there, yeah. So, you know, they normally try and pull it out, but sometimes it tears when they pull it out. And so it doesn't weigh much, so they leave it in there.
Right.
On this one, it's quite good. They've got some glass where the seat post goes in. So if you're running an aluminium seat post, you don't get that galvanic reaction, the corrosion between the carbon and the aluminium.
Mm-hmm.
So yeah, you know, so it's sort of like there's good and bad in almost everything. You know what I mean? So and talking about corrosion, here's an old Trek, and this one came to me years ago from a guy in, I think it was in Hong Kong or Singapore. Anyway, the bike was only a couple of years old, and he'd used it pretty thoroughly, but it's a couple of years old, and he sent it in to get a full ultrasound scan. And when I scanned, I said, mate, it's sort of beyond it, and you can see all this corrosion So all this white powder is basically aluminium that's corroded, and it's all through here, through the bottom bracket, and through where the dropout is. Like so basically, what happens is the carbon and the aluminium are at opposite ends of the galvanic scale, and so you end up with a battery, and the aluminium just dissolves over time. So, you know, even the threaded inserts here, like they're steel, and they've rusted, and you can see how it's delaminating all through here, because the as things corrode, they expand before they fall apart, and then that can delaminate the structure as well. So yeah, this is a really interesting one, just to show. And you know, and as I said, this was just after being used for a couple of years in Hong Kong or Singapore, where it's obviously really really humid.
And you mentioned some forks as well.
Yeah.
So that's the frames covered. Forks, I guess, are another mission critical part of a bike.
A couple of forks. What we see a lot is voids in the steerer. So, you know, you can see those air bubbles basically in the steerer, and unfortunately, air's not very strong. So, you know, it doesn't really take the design load, and it affects the compressive strength more than the tensile, because with the fibre, it's like a rope. When you pull a rope, it can take the load, but it can't take any compression. So the fibres need to be supported by the resin to take the compression. If that resin or other fibres aren't there, if it's just an air bubble there, then it'll buckle and it'll fail. So that's why that's sort of a critical, really critical thing on a fork, because especially in the middle of the fork, it's that's where you're going to get like, you know, this compression sort of buckling.
What sort of load are forks under? It's both compression, twisting.
Yeah, it's a really complex situation, because you basically, even in the head tube, you've got the bearing, and so as the thing will bend right in between the bearings, that's where you're going to get your maximum deflection. So, you know, and the longer the head tube on the bike, the longer the separation, the worse that is. So, you know, that's you often hear about the pros riding a smaller frame bike than what they, you know, than what's actually sized for them, but they're doing that to get more stiffness. Yeah, and so same sort of thing on this on this fork here. So voids in there. So yeah, it is quite a common thing, and it's always around this sort of region, primarily because of the way the forks are moulded. You have the bladder, they're moulded in one piece these days, and you have the bladder going down the legs, and then there's a transition of the bladder usually in this area, and it's at that transition where you get a lack of compaction, which then translates to voids. If you're not pressing the laminate down hard enough, any trapped air, and there's always going to be trapped air because you're laying these layers, the plies down individually by hand. Every time you put a layer down, there's always a little bit of air, because it's like when you're folding a piece of paper, there's air between the paper, and so you need the pressure to squeeze that out. So you know, that sort of thing is critical. And then we've got, I'll show you the wrinkle one, which is really obvious what a structural wrinkle is. So
very different build structure just from this over here, which has got a lot of meat in there compared to this one.
Yeah, so this has got a couple of issues with it. So, you know, you can see, like, it's been I've polished it a little bit, so you can see the actual runs of the fibre, and it sort of goes in and then it kicks out, and so that corner's really accentuated and it's further in, which is not ideal. You've got this massive wrinkle here, and you can see the fibre is actually going into that wrinkle and then out of it, and so when it's under load, it basically it can't take the load. All it's doing is cracking down that fold. You know, right. So you've got the situation like that, and under load, it just wants to open up. Whereas if you've got the fibre straight, you're just pulling straight across.
But from the outside, we can't tell that's like that at all, can we?
No,
So
that's right.
From that side there.
Yeah, there's no indication of it at all. So and
Wow.
and same with these voids. Like there's no indication of it at all. That's where the scan is useful. Like you with the ultrasound scan, or I mean that stuff you can see it on an X-ray or a CT scan. This one's interesting as well in that there's a fair bit of dry fibre down the fork legs. So where it's just a bit resin starved. And then in the dropouts you can see how it's sort of all this random fibre going along here, which is sort of a compression moulded piece. So
Now, I think I saw a lightweight wheel cut in half. Now, not a lot of us have the privilege of seeing a lightweight wheel in half. Well, it's not a good privilege to see, but I think some of us have seen it crashed.
yeah, I mean I've got quite a lot of them. It's just I'll go grab the one. They're actually really simple wheels.
So if you're half wheeling someone, this is pretty much what it's all about.
Half-wheeling, yeah. So they're actually really simple. So they've got a foam core and the carbon spokes, and there's not much to them really, and that's why they're so light, because there's not much in them.
So what is the white stuff inside? That's just filler?
That's foam.
That's foam filler.
That's foam. So it's not quite esky foam. It's a bit more advanced than that, but
so you can't keep your beers in there. Right?
No, it'd be good. It'd still be a good insulator, but it's probably just a higher density esky foam, effectively.
Right.
Yeah. Well, like what your helmet's made out of.
Yeah. Okay.
Yeah. So like that's structural. So helicopter blades are made the similar sort of way. So they use a foam and they put the carbon around the foam to provide the core. So, I mean, they're the two types. There's two types. There's foam core and there's honeycomb core. I've got a little bit of a sample. That's the honeycomb core, which is typical of an aircraft. But the zip discs, when you see that, you can see the honeycomb pattern because the skins are so thin on a zip disc. They use a honeycomb core through the most of it, because honeycomb cores are really, really lightweight stuff.
Right.
But on a rim section like that, it's too difficult. Honeycomb's really good for like big flat panels, and that's why. That's off a piece of 757 rudder. That's a skin off a rudder.
Right. So, okay. So that covers what you've been up to on Instagram lately. I'll run through a few quick ones for everyone. Now, first question: dangers of cutting carbon. If you're going to cut carbon yourself, what are a few tips to look out for?
Don't breathe it in. Like I wear a proper mask. I've got an extraction system here, so that extractor comes to this bench, and all these holes in the bench is my extraction. So when I'm sanding or cutting stuff here, it's all getting sucked away, as well as obviously wearing a mask and other personal protective equipment, glasses and stuff, goggles.
That's because the carbon fibres, the body can't recognise those. And can't
That's right. That's right. If you get a carbon splinter, and I've had carbon splinters over the years, and I think I've still got one in one of my fingers somewhere, and it doesn't bother me at all.
But it will never work its way out, though, will it?
That's right. That's right. It's in there. So it's like anything. Look after yourself.
And the correct tools?
Yeah, there's for cutting stuff with Dremel and a diamond wire works really,
I've
really
seen a German guy cut bodies open on telly with something similar to this. It's the same sort of.
So a little diamond wire like that, and it's that gives you a really nice cut. When you're cutting carbon, particularly steerers and seat posts, and we see a lot of this where someone's just gone into it with a hacksaw and they've delaminated it, because they're using force. If you're going to use a hacksaw, I'll show you you want to use one of these grit type blades. So you can get them either diamond or tungsten carbide grit, and they're like, instead of like a normal hacksaw blade with teeth in it,
which is for wood and steel and things.
Yeah, so a normal blade doesn't work well for metal, for carbon, because it's it loses its sharpness really quick because the carbon is so abrasive, it gets blunt really quick, and so like even just cutting one steerer with just a normal blade, like you get a brand new blade, cut a normal steerer. By the end of cutting the steerer, the blade is blunt, and what then happens is people force it. They want to finish the cut, they'll force it, and then they'll delaminate it. So we see a lot of the steerers at the they get delaminated on the edge, because people cut and then it basically folds the layers out. Yeah, okay. So don't use much pressure when you're cutting, and cut all the way around the steerer first, so that you don't have this edge of fibre which is just going to peel off. And I've seen forks, because it's all made out of unidirectional material, you can get a delamination go all the way down the steerer, and it's because it'll just travel down the line of it. So and it's just unnecessary, if you cut properly and don't use much force, use the right saw. I think there are bike tool companies which sell the carbide blades, but they sell them for like $40. You can go to Bunnings and get a tile saw, which is exactly the same for like $5 or something.
Good
like
tip.
So,
excellent.
So the tile saw, and that's what my blade is. It's just a tile saw one, and they work really well. But yeah, don't use much force. Don't put pressure on. Support it well. Take your time. It's like it's much more cost effective to spend a couple more minutes than to ruin your fork.
Brilliant. Okay, can we put all this into practice on a seat post of mine?
Yeah, we can do that.
Let's get into it.
Yeah, so that's what happens. Like, and you basically punch a hole through the back of the.
So if you use too much seat post, or if you're too short on a long frame, you can do some pretty damn.
So if the frame's the wrong size for you, and sometimes like a shop will have stock of one frame but not the right size frame, and
we've been there. We've all been there. Well, sorry, I've been there. My first bike wasn't the right size, but it wasn't carbon.
So it just goes as it goes down. It just bang out the back of it.
Wow.
There's a few brands which have a similar sort of design and they have the same sort of problem, but yeah. So you can see it like there's a minimum insert, so that's how much is the minimum required.
Right. Okay.
So that's so they're saying, what's it, 85 mil. I'll maybe take 80 mil off it.
Sure. Yep.
So we just mark where we're actually going to put it. So if we're going to take 80 mil off, it's almost basically right on that white line.
Now this will change, for those watching at home, this will change the minimum insert and what that means. So when I go to sell the bike or pass it on, I will let people know that we've done this.
So by wrapping the tape around it, okay, there's our 80 mil. It gives you a place to cut. So it's straight because it's a nice bit of wide tape, so it's only going to sit, like it's not going to be able to twist when you put it down. And that gives us our cut line. So we'll go and cut this guy.
Let's do it.
Extractor on. as you saw, I did a bit of sanding around it just to knock that sharp edge off.
Okay, so let's quick look at that. That's...
So you just, yeah. All right, and we'll put a bit of this stuff on.
Bit of carbon grip paste.
Yeah, this is the finish line stuff which I got at Interbike years ago, and it was sort of as a pre-production when they were just about to launch their product, and they.
So you use that on carbon forks and seat posts and handlebar clamps and everything with a carbon interface?
Yeah, it's just good practice to. It's like anything. Whenever you assemble, anything, you really need some assembly compound between it, and in the bike industry, typically they use grease, but there are better things than grease.
You can really hear that grit. It's not slipping anywhere. Good stuff.
I'll just nip it up a little bit with this first. So it's right on the tape where your position is, yeah?
That's it, yep.
And then get the old torque wrench.
You'd always use the torque setting printed on the actual component, or is it a general, this is what you use for seat posts, this is what you use for handlebars?
Yeah, good question. Like nowadays, most things have got, it's printed, what their recommended torque value is. It's typically between 4 and 7 Newton meters of torque. That's sort of the broad range. So I don't know if this one's got it printed on, but seeing it's a double clamp, I'd probably use it a little bit less. I'd probably be on the 4 side. I do see a lot of when they got the double bolts, you can tighten it incorrectly, and then the force you're putting through is just huge. So it's just what I tend to do is go to the lighter end. Now I'll just sort of feel that before I take it all the way, and then I'll go to the other side and see how this side's now totally loose, even though I nipped them up about the same before. And so we just sort of do them gradually and evenly, and there we go, that's that one. Just go back to this. See how that one's gone off.
Right, it's a bit of a balancing act between
yeah,
the two.
it's just.
Yep.
So you sort of, the goal is sort of to creep up to it, not just go bang, there it is. Mm-hmm. Just sort of go nice and gradually up to that point. I can't hear any creak, can you?
I hear nothing. How about that?
There we go.
The master at work. Raoul, thank you so much for all your work today. I will link to your Instagram below. I'll also link to Maven's other videos as well, because they've been brilliant, and they've got a lot of carbon insight, composites, and the knowledge you've passed on, which we all really, really appreciate.
Yeah, thanks.
So thank you very much for that, and we'll see you soon.
Yeah.
Actually, we'll see you in America, won't we?
Yeah. So I'm presenting at the Cyclic Tech 2016 conference in December, which is put on by the UCI and the composite society called the JEC and the SPE, Society of Plastic Engineering. Yes, there's some big players there. Cervelo, Boeing, all the brands are going to be there. And I'm the only one from Australia presenting. So
really, they've picked the right guy, I think.
So it should be really good. So I'm presenting on ultrasonic inspection of like the stuff I've found in bikes over the years. So these pictures, these cut up bikes, things that I'm showing in this video that's sort of what the basic content. I mean, over the years, I've scanned probably 3,500 bicycles. And so I've got a fairly good database of stuff.
I think there's a lot of stuff we can continue to cover in the near future. So thank you again, Raoul, and we'll see you soon.
Yeah, pleasure.
Cheers, mate.
Cheers.